Good day. I'm Steve Krause, and welcome to the webinar for the PCO-7115 5-1 product launch. Looking forward to introducing this product to you today. Normally we would have Marty Jones here. Unfortunately, we've had some weather here in Colorado and he's unable to join us. So we are going to change our format just a little bit, but I think you'll find that we'll get the information out to you just fine. So the first thing I want to do is let you guys know that this is a recorded webinar. So you'll have the opportunity to review the information later. We'll post a link on our website. And if you have a colleague who wasn't able to join us today, that you can forward the link to them and they'll be able to view it as well. There is a chat icon at the bottom of the application screen. So if you have a question or if something in the webinar isn't working, go ahead and let us know. Just chat something in there. And at this point, you should see the slide, kind of the introduction slide with the notes about what I'm talking about right now on, and you should be able to hear the audio. So go ahead and use that chat window real quick and just let me know that you're able to hear the audio and see the video as well. And while we're doing that, I will go ahead and talk about the rest of the logistics of the webinar. We'll be answering questions live at the end of the webinar. And if you have a question that is that involves either a complicated situation that would be impractical to address over a webinar situation or a chat situation, or involves intellectual property, that would be, go ahead and contact us at sales@directedenergy.com or just give us a phone call at 970-493-1901. And that's the best way to get a hold of us for those complicated or kind of private conversations. And finally, at the end of the webinar, we will have an opportunity for you to provide us some feedback. We always like to make these as good as they can be. And so any kind of constructive criticism would be much appreciated. All right, so what we're going to cover today is we're going to do an introductory video. And so we'll put that, I'll roll that here in a few minutes. That video is going to cover basically the product overview, and you may have already gone to the website and seen the product video that's there now. That video is a very brief introductory video that's meant for people who really just want to know kind of the overview of the product. The video we're going to roll in a few minutes is about 10 minutes long, but it goes into depth about setting up the PCO-7115 and operating procedures and stuff like that. So I think it'll be a lot more in depth and you'll get a lot out of it. We'll talk about what's in the box, what accessories are available. As I mentioned, we'll do the technical overview, how to set it up. And then in the last part of the video, there'll be some tips for safety and performance for operating the 7115 and getting the most out of it. When that's complete, we'll go back to this semi-live webinar. We don't have video today because, as I mentioned, I don't have someone to operate the cameras. So we'll just do the audio portion, but that will be live. And we'll talk about price and availability. We'll talk about the Lab to Launch program briefly, and then we'll open it up for questions and answers. All right, so now I'm going to go ahead and roll that video. And so sit back and relax and take a look. Stephen Krause with Directed Energy here to introduce the PCO-7115 5-1 laser diode driver module. When you need to integrate a high-speed pulse laser into your application, the PCO series offers off-the-shelf, easy-to-use modules in a variety of standard configurations, centered on compliance voltage, output current, pulse width, and frequency. They're designed to be easy to use right out of the box, and simple to integrate into your product, system, or experiment. Featuring a 1 nanosecond pulse width at up to 5 amps, the PCO-7115 provides a fast, high-energy pulse to your laser diode. The fixed pulse width means less for you to configure and optimized pulse performance. In the box, you'll find the PCO-7115-5-1 laser diode driver module, the operating manual, and the control cable. For volume orders into OEM applications, you can select whether you would like the control cable and manual for each module. 4 mounting holes make it easy to install the module in your own finished product, local installation, or test platform. The control cable is included and provides an easy way to connect the trigger, 24-volt support power, and the high-voltage supply from your system. Your TO5, TO18, 52, 5.6mm, and 9mm diode will mount directly to the module. For other diode packages, or situations where the mounting of the diode on the printed circuit board is impractical, 2 tabs allow the use of our low-inductance strip line. Monitoring the current pulse is an important way to verify the operation of your diode, characterize your design, or troubleshoot your system. Safely and accurately monitoring a current pulse is as simple as attaching the PCA-7245 current monitor cable to your module and to your oscilloscope. Let's dive into a technical overview of the PCO-7115. This graphic shows the key operating specifications. The output current range is from 500 milliamps to 5 amps. The module has an output pulse width of 1 nanosecond and a rise time of less than 1 nanosecond. There's a small throughput delay of about 37 nanoseconds. Frequency capability from single shot up to 1 MHz provides flexibility for a broad range of applications. A standard 5-volt signal can be used to trigger the module's pulse. By supplying less than 200 volts at 20 milliamps, you can get high-speed, high-frequency pulse performance delivered to your laser diode. The scope shot on the right shows a typical current pulse from the PCO-7115-5-1. The peak current is 5 amps with a pulse width of less than 1 nanosecond at a frequency of 1 MHz into a shorted load. The high voltage DC input is 150 volts. In this example, the oscilloscope signal has been inverted to provide a better visual demonstration of the unit's performance. The pulse width is measured at full width half max, or as you can see in this example, at the 2.5 amp level. In this slide, you'll find a chart showing the safe operating area with high voltage input versus frequency for each current setting in half amp increments. This chart will help you set the voltage prior to enabling the device. Depending on the characteristics of your laser diode, you may have to adjust the high voltage to get the current you desire. For example, if you want a 3.5 amp output at 1 MHz, then we locate 3.5 amps, which is the blue line between 70 and 80 volts on the left-hand side of the chart. We will follow this line to the right to our desired frequency. In this case, we'll use 1 MHz, which is located at the far right of the chart and is the maximum operating frequency of the PCO-7115. At this point, we see the high voltage input is around 80 volts. This would be your starting voltage set point at this current level. The physical dimensions of the PCO-7115 are 2.5 inches long by 1.5 inches wide and 1/2 inch tall. The PCO-7115 is designed to be easily integrated into a larger system. However, it is simple to operate independently on your bench as well. Before we begin the setup, let's review the equipment you'll need to operate the module. A 24-volt power supply supplies standard support power for the driver's operating circuitry. A high-voltage adjustable power supply with a maximum voltage of 190 volts will provide the power needed to drive the laser itself. The trigger input can be provided by a common 5-volt pulse generator capable of driving a 50-ohm load. With this standard lab equipment, you'll be able to drive your laser. In order to monitor the module's output current pulse, you will need an oscilloscope and our optional current monitor cable. Now that we've covered what equipment is needed, let's set up the PCO-7115-5-1. When you open the box, you'll find the operating manual, the control cable, and the ESD safe box containing your PCO-7115. Next, we will solder the laser to the location marked D3 on the PCO-7115. For the purposes of this video, we used an LED instead of a laser. The cathode is connected to the strip line pad, and the anode is connected to the positive output pads. Your own installation will depend on the diode package you're using. Next, you'll need to strip the wires of the control cable back approximately 1/4 of an inch, or terminate the wires appropriately to connect to your own installation or equipment. To attach the trigger wires to the pulse generator, you'll use the orange wire as the trigger signal and the associated black wire as the return. For our demonstration, we used a banana to BNC jack to convert the twisted pair to a BNC connection. Now let's connect the 24-volt supply. The red wire is the positive 24 volts, and the black wire is the 24-volt return. In this case, our power supply has screw terminals, so no additional hardware was required. Now it's time to connect the high voltage DC power supply. The blue wire is the positive high voltage, and the black wire is the high voltage return. In this demonstration, we daisy chained two DC power supplies in order to supply us with 80 volts. This configuration should only be used according to the proper operation of your power supply. Once you have connected your control cable to the support equipment, you can connect the other end of the cable to the PCO-7115 at the connector labeled J1. If you purchase the optional current monitor cable, you can connect it to J2. Connect the BNC connector from the current monitor cable to your oscilloscope and set your oscilloscope input to 50 ohms termination. Now you're ready to adjust the trigger settings of the pulse generator. In this example, we've set it to 1 MHz with a 50 nanosecond pulse width. Here at Directed Energy, we normally invert the oscilloscope channel input. This is optional. However, without the input inverted, you will see your current pulse going negative instead of positive. Set the oscilloscope resolution to 1 nanosecond per division and 200 millivolts per division. Now it's time to apply power to the PCO-7115. First, turn on the 24-volt DC supply. Next, turn on the high voltage power supply. We've set ours to 80 volts, which results in the 50 nanosecond pulse at 1 MHz and 2 amps, which we described earlier. To enable the output pulse, turn on the trigger source. You will now see a current pulse on your oscilloscope. With 80 volts of high voltage, you should see a 1 volt peak representing the 2 amp output. In the next example, we use approximately 12 inches of optional strip line to connect our diode. As you can see from this oscilloscope photo, the peak current is still 2 amps, but the pulse width is slightly larger and there's a modest ring on the trailing edge. This is due to an increase in parasitic inductance on the output. To demonstrate the importance of a low inductance diode connection, here we use 1.5 inches of 22 gauge wire to connect the LED. You can see from this photo that the current output is distorted and below the previous 2 amp output. In this slide, we show all three methods of connecting your diode to the PCO-7115 side by side. Before we wrap up, let's cover some operating tips for safety and performance. First, you must have a load attached to the output to enable the flow of current. If you're not measuring any current or seeing light from your laser, make sure your load is installed properly. Only measure the output current using the optional current monitor cable. This is a high side laser diode driver, and alternative methods, such as measuring across the laser diode itself, could damage both your oscilloscope and laser. Do not handle the PCO-7115 with voltage applied. There are high voltages present on the board. Always make sure your input trigger source is greater than 4.5 volts. Be sure to attach your laser directly to the unit or use a short length of strip line, and avoid using straight bus wire or twisted pair wire. When measuring the current using the current monitor or IMON at J2, ensure your oscilloscope is terminated into 50 ohms. Well, that wraps up this introduction to the PCO-7115-5-1 laser diode driver module. Thank you for watching. Contact us with any questions by phone at 970-493-1901, by email at sales@directedenergy.com, or visit our website at directedenergy.com. Okay, so that wraps up the video, and we'll go ahead and get into the pricing and availability. Again, if you have any questions at all about the information that was presented in the video, put them in the chat. You can go ahead and do that now. I'll answer them at the end of the presentation. And if you have any additional questions or technical questions as well, go ahead and put them in the chat. So pricing and availability, the US MSRP for the 7115 is starting at $102.50. Outside the United States, you'll need to contact a local representative if there is one in your specific geographic region, or you can contact us directly if there isn't one listed on our website for your country. Currently, we have units in stock, and normally we expect to keep them in stock with the exceptions of maybe up to 4 weeks of lead time, depending on demand. So I always like to talk a little bit about the Lab to Launch program when we do these webinars. And what the Lab to Launch program is an opportunity for customers to work with us directly to get a module or an instrument that really narrows down the performance to exactly what they need. So, for example, our instruments, a lot of them have a wide operating area, so they can cover a lot of applications. But when you're trying to develop an OEM product and you're trying to pull cost out of it, to be honest, and get it to the market, you may only need a very narrow operating configuration for a specific thing, for a laser diode. And so you don't want to pay for functionality that you don't need. And so that also impacts size. So you don't want to have the cost of functionality you don't need, and you don't want the cost, or you don't want the size for added features and functions that are not going to be important to your application. So what we do is we work with customers to, and you may start with one of our instruments or one of the modules that has a broad range of operating capability, and as we work together, you'll start to narrow down in your prototyping and in your experimentation exactly what you need for your final product, and then we can begin to work with you to provide you exactly that module, whether it's an open frame module like the PCO-7115, or an enclosed module like the PIM Mini, for example, or even a full rack mount system like the 7500, or one of those products where maybe your installation requires a great deal of power, or it has a broad functionality or a broad range of operating parameters that are required. So all of those options are available, and we work with you until we've gotten that narrowed down. We do the design, and then the manufacturing is done in an ISO registered facility. They're tested by our team, and when we deliver them to you, they are ready for installation. They're ready to go into your product. So you can worry about the part of the product that you bring expertise to, and we can worry about driving the laser. It gives you one less thing to worry about. When we ship it to you, you're going to put it in your instrument, and it's going to work, and you're going to be ready to go. So I always like to introduce that, especially with these modules, because this is, sometimes the Lab to Launch program is about creating a whole new product, and oftentimes it's also about modifying an existing product like the 7115. Maybe the 5 amps in 1 nanosecond isn't exactly what you need. Maybe you needed a little more current, or a longer pulse width, and we can maybe a modified version of that product will suit you just fine. So always like to introduce that. We're going to go ahead and at this point, we'll go ahead and move on to the Q&A section. This part, it tends to get, can go a little bit long, and there can be a lot of silence. So I would ask you to bear with me as we go through this. It takes people time to put questions into the chat. I will be here, so if it goes quiet, that doesn't mean I'm gone. It just means that we're waiting for people to go ahead and put questions into the chat window. When I've answered all the questions that are there, we'll go ahead and wrap up and get on with our days. So there is a question. The first question that was typed in is, are other current and pulse width configurations available for the 7115? Right now, we're introducing the product with the 5 amp 1 nanosecond configuration. So there aren't any standard configurations that are different from that available at this time. As soon as, if we discover one that a lot of people are looking for, we'll go ahead and introduce that, or we may start adding configurations in the future. But again, I'd like to just mention that if there is something that's slightly different than what we're already offering, please go ahead and let us know, either, you can ask in the chat or send us an email at sales@directedenergy.com. And we can work with you to go ahead and provide a configuration. If it's close enough to the performance of the 7115 or within the capability of the design, we'll definitely go the route of modifying that board in terms of modifying the bill of materials. That's a very economical way to get a custom product versus doing the ground up development, which is sometimes appropriate, but obviously costs a little bit more. So I hope that answers your question. All right. Well, there's nobody typing, and looks like I'm going to get off easy today on questions. I would like to respect everybody's time. So at this point, we'll go ahead and wrap up. If I didn't get to a question, or you're busy typing one in and I'm cutting you off, I apologize. Go ahead and email us at sales@directedenergy.com, or give me a call at 970-493-1901. And at this point, again, if there's anything we can do to make this type of webinar more useful to you, more valuable, please let us know. We always want, like I said before, we always want these to be a very valuable use of your time. I also try to keep them as brief as I can, and so because I also want to respect your time. So I appreciate your time this morning, and have a great week.